and Mom and Dad set up our famous 10-foot long ladder against our Christmas tree. My sister Lucille and I are finally old enough to reach the middle of the tree to put up ornaments. My younger sister Casey, she loses her balance while she tries to put an ornament on the tree, which wobbles the tree and offsets the ladder, and it starts to slide away at a rate of 1/4 feet per second. So we need to try to find out how fast the ladder is sliding down when the ladder is 8 feet above the ground, so Lucille and I can get out of the way in time. So the constant here, the length of the ladder is the 10 feet, and it's sliding away at 1/4 feet per second, which is dx dt, and x, the distance from the bottom of the ladder and the bottom of the tree is 6 feet, and the distance from the top of the ladder to the base of the tree is 8 feet. So we're going to use a formula for Pythagorean theorem, x squared plus y squared equals z squared, and as we mentioned earlier, z is going to be 10 feet, so we're going to plug that in for z, the length of the ladder. So you're going to have x squared plus y squared equals 10 squared. And when you take the derivative of that, you're going to multiply the exponent by the coefficient and subtract 1 from the power. So 2 times 1 is 2 times x with no power, and the derivative of x is dx over dt, plus 2 times 1, 2y, times dy over dt, which is the derivative of y, and 10 squared is 100, so that's essentially going to be 0.
Okay, so now we're going to start on our work. So we are going to use our formula for the derivative, which is 2x dx dt plus 2y dy dt equals 0. And then we're going to start pulling numbers from our picture right here. So first we are going to plug in 6 for x, which is right here. This is not a constant, so it's not going to be plugged into the original equation. And then next we're going to plug in 1/4 feet per second, again, also not a constant, so we are also going to be plugging this in for dx over dt. Next, we are going to use the 8, which is our y value of the height from the top of the ladder from the base of the tree at the time we're looking at, and we are going to plug that into our y value. So we're looking for dy over dt, so we're going to start moving numbers around to set this equation equal. So first, multiply everything, set everything, simplify it, and then move your 3 over to the other side. So now you're left with 16 dy over dt equals -3. And now all you have to do is divide -3 by 16, which is going to be your dy dt, or the rate at which the ladder is moving down the tree. And that's your final answer. Dy over dt equals -3/16 feet per second.
Now that we know the ladder is falling at -3/16 feet per second, we want to know approximately how much time do the children have to escape the falling ladder. In the picture representation, 2 children are standing at the base of the tree, and the top point of the children reaches 4 feet, or the middle of the tree, which is the distance that they can reach. The ladder is falling at -3/16 feet per second, so using a cross multiplication technique, we will put that on the left side of the equation. On the right side, we will have -4 divided by x. -4 is a representation of the distance that the ladder will need to drop before it hits the children's head so they can get out of the way in time. -3x equals -64 is our equation after we cross multiply the numbers, and that will give you x equals 64 divided by 3, and the negatives will cancel out because a negative divided by a negative is always a positive. The children will have approximately 21 seconds to get out of the way of the falling ladder, or 21.333 seconds to get out of the way of the ladder. Again, this is an approximation because the rate of change of the falling ladder will not stay constant.